If you find yourself getting frustrated or running out of time because you're digging through notes, or even if you think you're not, but you are, my advice is to try to start to do things from memory and not from notes. So this one says, oh, let me just do my attendance real fast. Still no teller. Okay, so number 1 says secant of x minus 1 and secant of x plus 1. Well, first of all, let me just say, I would probably write out your Pythagorean identities because those are the ones we don't know off the top of our head that we definitely need to know. So the first one is sine squared plus cosine squared equals 1. If I divide all of that by cosine, I get tangent squared plus 1 equals secant squared. And if I divide the original all by sine, I get 1 plus cotangent squared equals cosecant squared. So that helps me with the Pythagorean identities. Obviously, the other ones, hopefully, the other ones you should know off the top of your head, I would say. So what would you normally do if I had 2 parentheses like that? Oh, it's you. Thank you. Where you don't answer me. You would FOIL them. Yes, I forgot who I was talking to. Silly me. You would FOIL them. So if I distribute, secant times secant is secant squared x. Secant times 1 is secant x. Negative 1, secant minus secant x. And then negative 1, positive 1, negative 1. So the positive secant and the negative secant cancel out. And then I get secant squared x minus 1. Again, train yourself so that as soon as you see secants, or as soon as you see a function squared, especially with another term, go back to your Pythagorean identities. So if I look at that second one, I've got secant and I've got 1. It's just that they're not on the same side yet. So if I subtract the 1, I'd get tangent squared equals secant squared minus 1. So this becomes tangent squared x. So if I am writing this, because you have to think about it, right, in terms of a Canvas quiz now, if I'm writing that as a Canvas quiz, that would be tan, the little caret, 2, and then x. And I would probably take, like, either one of those, something like that. Number 2 says simplify the given expression, secant squared x times 1 minus sine squared x. So what can I do here?
You can switch out the 1 minus sine to 2 cosecant.
Cosine.
Cosine.
Right, good. Cosine. And then what?
And then you can flip the cosecant, like 2, 1 over, and then cross multiply.
Good. Yep. And 1's as simple as it gets. Number 3, I've got 2 separate fractions, right? So what's the trick we talked about on Friday before we left that I said was usually pretty helpful?
You can move it from the top to bottom.
You can move it from the top to bottom. So if I move cosine to the top, it becomes what? What's the reciprocal of cosine?
Secant.
Secant. Thank you, son. And I'd get secant times secant, or secant squared x. I move cotangent from the bottom to the top, and it becomes its reciprocal, which is tangent, and I get tan squared x. There's a Pythagorean identity that has tangent and secant, but it's not on, they're not on the same side. Secant minus tangent means this is moving over here, and I get just 1. Questions so far? All right, like I said, 3. So 5-3 is solving trig equations. If you were good at 4-7, which was like I gave you the trig function, you gave me the angle, that's like almost half the battle with this. Obviously, it's a little bit different. We're going to restrict our answers a little bit differently. There are more than one answers this time because it's not inverse trig functions, it's just solving them. But that is the general concept. I give you the answer, you give me the angle, okay? So the first thing is just says verify that the given value is a solution to this. So if I had 2 cosine of x plus 1 equals 0, and I'm telling you that x equals 2 pi over 3, and it says it's a solution because there can be more than one. But to check this, I could just plug it in. So 2 times the cosine of 2 pi over 3 plus 1 equals 0. So I have to figure out what cosine of 2 pi over 3 is. This is where my unit circle comes into play. Or knowing your unit circle, right? If it's an over 3, I know the coordinate point is 1/2 and root 3 over 2. And if it's 2 pi over 3, it's in the second quadrant, which means it's a negative 1/2 and root 3 over 2. So I'd get 2 times negative 1/2 plus 1 equals 0. 2 times negative 1/2 is negative 1. Negative 1 plus 1 is 0. So the whole point of this example is to say every single question in this grouping of types of problems can be checked. You can take your answer, you can plug it back in, and you can check it. All of this is going to be in radians.
Excuse me, Lizer?
Yeah.
If we get like this question on the homework tonight, how do we input that?
Your work would just be your answer. I actually think, oh, Taylor. I'm trying to think if there is one like that on WebAssign. I don't even remember. Let me check. Okay, so this is like the real process of solving to find an angle. So you're going to locate the solution on the unit circle. Sometimes it's just already given to you. Sometimes you got to do a little bit of work to get to it. But you're going to locate that solution on the unit circle. There will be, for almost all of them, more than one answer because we're using our true unit circle. And then there's 2 types of problems. One where it doesn't restrict your interval, which means I'm going to take every answer I get from sine and cosine, and I'm going to add 2k pi, and actually that might be a lie because let me check the variable on WebAssign, I think is 2n pi. Which means not only does it happen at that angle, it happens at all of that angle's coterminal angles, which should make sense. Every time I add 2 pi to it, I get another angle in which that would work. Then, if it's tangent, I add k pi, because tangent happens every half pi. Sorry, every half circle, which is the same thing as pi. Yeah, so it's actually 2n pi. N and k just represent a constant, okay? Which means if my answer was like pi over 4, let's say, I can add 1 2 pi to it. I can add 2 2 pi's to it. I can add 3 2 pi's to it. Yeah. And I can keep going around that circle and it would still be the same point. So that n pi is just a variable that represents a constant that can be changed. Yeah, Sai, to answer your question, none of them are actually like that. They're all, I just was showing you that you could check them. And the first one is in degrees. You'll see it when you get there, but the rest are in radians. All right, so then let's say I'm looking at my original angles. So to figure out which ones I'm going to use, for sine and cosine, I use my entire unit circle all the way around. And for tangent, I go negative pi over 2 to positive pi over 2. So tangent, we restrict differently. Okay, and then we would add n pi. So if an answer for sine was pi over 4, it would be pi over 4 plus 2n pi. And if it was sine or cosine. And if it was tangent and my answer was like pi over 4, then it would be plus n pi. Because you'd add half a circle and it would happen every time. Let's see what this looks like. So the first thing I would say is either know your unit circle off the top of your head or bring in your snapshot of it because you're going to need it. All right, so notice it says solve because in a little bit it's going to say something about solve and a restricted interval, and that's different. This one says solve. So the first one says sine of theta equals a half. So sine is which coordinate, x or y? Y. So I'm basically looking for every y value that is positive 1/2 on my unit circle. Positive 1/2 happens here, and it happens here, which means my two basic unit circle answers are pi over 6 and 5 pi over 6. But then to these we add 2n pi, because not only does it happen at those two angles, it also happens at all the coterminal angles of those angles. B says cosine negative root 3 over 2. So cosine, we're looking for the x, right? Where is my x? Negative root 3 over 2. Go ahead.
7 pi over 6.
7 pi over 6. One more.
And 5 pi over 6.
Good. So 5 pi over 6, 7 pi over 6, and to each of these we add 2n pi. And C says tangent. So this is why it's super helpful to add on your tangents. Okay, so remember that this is root 3 over 3. This is 1. This is root 3. This is 0. This is negative root 3 over 3. This is negative 1 and negative root 3 and undefined and undefined. So where on my unit circle, in my tangents, right, which is actually the negative angles, negative pi over 6, negative pi over 4, negative pi over 3, negative pi over 2. Where is tangent negative 1?
7 pi over 4.
Which would be what in the negative version?
Negative pi over 4.
Negative pi over 4 plus n pi, because tangent we add half the circle, or n pi.
Ms. Christopherson?
Yep.
So just the answer is just like negative pi over 4 plus n pi. That's what you put?
Correct.
Huh.
So when is it n pi? When is it 2n pi? Is it
It's-
when it's tangent?
Correct. N pi is just tangent, because look what happens to my pattern of tangent. It's negative, like let's say I just pick out negative 1. It's negative 1 here. That'd be helpful and highlight. Here, and then it's negative 1 here. It's half the circle every time I skip. It's positive 1 here and here, half the circle. But sine and cosine don't follow that same pattern, right? Sine is positive in the top two, cosine's positive in the right two, so you can't use them the same way. So for sine, we correct. We go all the way around. We give both answers and we go all the way around. Tangent, we give one answer and we go halfway around.
So it could have been 3
Okay,
pi
thank
over
you.
4 too.
So it could have been.
The answer could have been 3 pi over 4.
So if it asks, is that negative 1? Yes, but when you want it in the right context, it has to be negative pi over 4 plus n pi. That's where tangent's negative 1. So for
It'd also be 7 pi over 4.
right, but just like for the inverse trig functions, you had to use the negative angles of tangent. We use the negative angles of tangent still.
Okay.
All right, so now we're going to do a little bit of work on the front side. We're going to isolate. Yeah.
How did you get negative pi over 4? I don't get it.
So like I was saying, you're going to do a little bit of work on the front. You're going to have to isolate the trig function first and then use the unit circle like we just did. So we're going to do a little bit of work at the front end. If you look at A, 4 sine squared x minus 2 equals 0. How would I normally solve it if it said 4x squared minus 2 equals 0? How would you solve for x?
Bring the 2 to the other side.
Okay, add the 2. So I'm going to do the same thing. Add the 2. Then what?
Divide the 4.
Divide by 4. And I get sine squared x equals 2 or 4 or 1/2. Then what? square root. Putting a plus and minus in the front of it. Square root of 1 is 1 over square root 2, and that gets rationalized to root 2 over 2. So because it's plus and minus, I'm going to have 4 answers here. Because it's all the positives and all the negatives. Where is sine root 2 over 2? All the over what's?
Over 4.
All the over 4s. So I get pi over 4 plus 2n pi, 3 pi over 4 plus 2n pi, 5 pi over 4 plus 2n pi, and 7 pi over 4 plus 2n pi.
Why is it all of the over 4s?
Because it's plus and minus.
But why the over 4s?
Because that's where sine is root 2 over 2, right? Think about, this is what's killing us on the notes. Usually by this point, we're so down with our unit circle, I should be able to pull that from your brain like that. This is when it feels different in COVID and the notes, okay? Every over 4 is root 2 over 2. And so that means the sine and the cosine are both root 2 over 2 there.
So what do you do with the 1 over root 2?
You had to rationalize it. So multiply both the top and the bottom by root 2.
Mr. Schwarzer?
Yep.
So on the quiz, how are we going to know whether to use Pythagorean identities or just solve the equation like we just did now?
It will say solve the equation, and the other ones will say verify.
Oh, okay.
Yeah. All right, B. What would you do there?
Take out sine x and then put sine minus 1.
Good. Greatest common factor actually says we can factor that, right? Take out the sine of x, and I get sine times sine of x minus 1 equals 0. So because it's a product, if either one of those is 0, the whole thing's 0, right? So we split and solve it like it's two different ones. Sine of x equals 0. That equation's done. Sine of x minus 1 equals 0, and I get sine of x equals 1. Now, think about your unit circle. Sine is your y. Where is y 0 on your unit circle?
And pi over 2.
At 0 and pi over 2, right? So we do 0 because I'm going to add 2 pi to it. Where else is sine 0?
At pi.
At pi. How about where is sine positive 1?
Pi over 2.
Pi over 2, and only pi over 2, right? Pi over 2 plus 2n pi. So the homework will say list these, separate them with a comma. Order doesn't matter on homework, okay? If it was for your test, it would probably, or quiz, it would probably say in order from least to greatest. So you would do 2 plus 2n and the word pi, pi like that. You would do pi, which is pi plus 2n pi, and then you would do, actually if I went in order that would be wrong. I would do pi divided by 2 plus 2n pi, and then I would do pi plus 2n pi. I really miss paper tests. It's just yucky. No spaces. Homework, this is how it goes. If it was an open-ended question, you'd have it like that on your quiz. All right, how about C? What would you do first? Move the 1. So 3 tan squared theta equals 1. Then divide by 3. Tan squared theta equals 1 over 3. plus and minus the square root. Square root of 1 over square root 3 gets rationalized. Plus and minus root 3 over 3. So remember, tangent, we're looking at the right side, right? The negatives and the positives, but that's positive and negative. So it's both negative pi over 6 and positive pi over 6 plus n pi plus n pi. Questions on those?
Mr. Clarkin?
Oh, you go.
Alright. Wouldn't it be 4 different angles because it's plus minus?
For sine and cosine, yes, because we add 2 pi. But for tangent, we only add 1 pi, which means we only include half of our circle.
Oh, okay, thank you.
You're welcome. Technically, it's not wrong to say all 4 because you're adding it in intervals. But if you're trying to like match a format, like a question specifically, it's going to be like that. If it was open-ended and you gave me all 4, I probably would still count it. Just realize that on Canvas it's going to mark it wrong. And if it's a multiple choice or something like that, it's going to be written like that.
So this is like last chapter where we had the unit circle and the tan is only the...
But just for tangent, Matt. The other 2, you use the whole circle.
Right, okay, and it's going to be like negative pi over 6 instead of whatever...
Exactly.
The equivalent would be in the fourth quadrant. It would be, we have to flip them.
Correct,
Okay.
Exactly. Yep.
Even for sine and cosine, you do like negative 5 or 6?
No, sine and cosine, you use the true natural unit circle.
Okay, thank you.
You're welcome. All right, let's keep going. What's the first step for D?
Lower the 4.
Add the 4. Then divide by 3. Then plus and minus. Plus and minus square root of 4 is 2 over square root 3. Now before you rationalize, this is a reciprocal function, right? What's the reciprocal of cosecant? Sine. So flip it, because you're going to just have to then rationalize the rationalized thing. So this becomes sine of x equals plus and minus root 3 over 2. So flip the reciprocal, flip the function, flip the equation, or the fraction. So where is sine? Root 3 over 2. And it's a plus and minus, which means all the over what's?
Over 3.
Good. All the over 3's. Pi over 3 plus 2n pi. 2 pi over 3 plus 2n pi. 4 pi over 3 plus 2n pi. And 5 pi over 3 plus 2n pi. Okay, go to E. What do you do here?
No, the other one.
Yes.
Factor.
The other F word, yes. Factor, yeah. So if you want to substitute like a in for cosine and factor it that way, like 2a squared plus a minus 1, factor it that way and then plug your cosine back in at the end, you can. Okay, you could also just keep it. So it'd be 2 cosine x and cosine of x. And then I'm trying to find the factors of negative 1 so that when I did outer and inner, I get positive 1. So it's a positive 1 and a negative 1. That gives me 2x minus 1x, which is just 1. Now, set them each equal to 0. 2 cosine of x equals 1. Cosine of x equals 1/2. And cosine of x equals negative 1. So where on my true unit circle is cosine of positive 1/2? Good. Pi over 3, 5 pi over 3, plus 2n pi, plus 2n pi. Where is cosine negative 1? Good. Plus 2n pi. Questions so far? All right, so now here's where 5, 1, 5, 2 come back into play. F has two different functions. You can't do that. I have to rewrite these so that one is in terms of the other, okay? So what's the relationship that I have with cosine and sine if you think about all of your initial trig identity stuff?
For 2 sine 2x, it may be if you like somehow remove the 2, you could put cosine, cosine 2 squared minus 1.
So, yep. So your trig identity that has both sine squared and cosine squared in it is sine squared plus cosine squared equals 1, which means I can't replace cosine to the first, but I can replace sine squared. Sine squared would be the same thing as 1 minus cosine squared. So in place of that sine squared, I put 1 minus cosine squared. Then I would distribute the 2 here. As soon as you see the cosine and the cosine squared, you should be triggered that you're going to have to factor this. So I'm going to get everything to one side. Subtract the 2. Those actually cancel. Add the 2 cosine x squared just because I don't like a negative leading one. And I get 0 equals 2 cosine squared x plus cosine x. Now it's not a 3-term factor, a trinomial factor, but there is a greatest common factor there that I can take out. Now I can set them each equal to 0. And I get cosine equals 0, cosine 2 cosine x equals negative 1, and cosine of x equals negative 1/2. And your cosine is 0 at pi and at 0. Nope, sorry, just kidding. Your cosine is 0 at pi over 2 and 3 pi over 2. And your cosine is negative 1/2 at 2 pi over 3 and 4 pi over 3. So that one requires substitution at the beginning and then solving. So you cannot solve it if they are different trig functions. You've got to be able to write one in terms of the other. All of the trig identities can be used this way though. So think it could have been sine and cosine, it could have been tangent and secant, it could have been cosecant and cotangent, and you would manipulate your Pythagorean identities to plug one in for the other. Questions on that one? All right, this one says find all the solutions on the interval of 0 to 2 pi. So this actually should be a parentheses. Then use the table feature of the graphing utility to check your answers numerically. So we're going to ignore that part because you're not going to have your graphing utility in your quiz. Yeah?
Can you go back for like 1 second?
Sure. So even though the instructions here are longer, this is actually easier. This is saying stop at 2 pi. Don't add the 2n pi. That's basically what it means. So instead of having to add on my interval, it literally just says use your true unit circle. So if you don't see it on that unit circle, don't include it. So I'm going to first take that negative 2, move it to the left side because I'm going to have to factor. Put my parentheses. This would be secant of x and secant of x. Factors of negative 2 that sum to negative 1, negative 2, positive 1. solve it. Hello.
Well, good morning, all.
So secant is not on my unit circle, but it's reciprocal. I will flip it so that its cosine is reciprocal of -1, still -1. Now we use only the values on our original unit circle. So if this was tangent, I would use 0 to 2 pi. I would not use the negative angles. But this is cosine, so I look at all the x values, and I find everywhere my x is positive 1/2, which is at pi over 3, and 5 pi over 3. And everywhere my cosine is -1, which is pi. And I only give those values. So I don't need to add the 2n pi if the interval is restricted. Called multiple angle equations. So it's actually not difficult, but if you tried to figure this out on your own, you would hate life. So pay attention to me. I'll teach you how to do it, and then you'll be fine. But they are more difficult than normal, okay? So the first one says sine of 4x equals 1. The 4 is attached to the x, so I can do nothing with it until I get rid of the sign, which means I actually have to find the solution first. And then instead of it being x equals that, it's 4x equals that. So I'm going to ignore it at the beginning, and I'm just going to say, tell me where sine is positive 1. What's the answer?
Pi over 2.
Pi over 2. So my answer is normally pi over 2 plus 2n pi. That's it, right? But that's when this is just x. So I would say x equals that. That's my answer. The difference this time is not just x. It's 4x equals that. So I have to remember to, at the end, divide everything by 4. That means I take my original pi over 2, divide it by a 4, or multiply it by a 4th. I get pi over 8. And also change your interval. So 2 goes into 4 twice. And my whole answer there changes. Pi over 8 plus n pi over 2. So not just the original angle, but also the interval changes. Now B says tangent of x over 3. So again, I ignored the x over 3 in the beginning, and I just find the answer for where is tangent 1?
Pi over 4.
Pi over 4 plus n pi. And again, if that was just x, I'd be done. But it's not. It's x over 3 equals that. So this time, how do I get rid of the over 3? Multiply everything by 3. So it cancels from here. I get 3 pi over 4 plus 3n pi. Easy stuff, right? It's different, but it's not difficult. The least fun of this kind of stuff is when it restricts your interval, which I will save for tomorrow. We'll talk about what happens there, because, wait, let me make sure. I think previous to today meet worked it out so that I don't need to separate that out.
Mr. Chris,
Yeah.
Can I ask a homework question from last night?
Sure. So this is factor by grouping. Group. I could take out a cosecant squared here. I could take out a -1. Then the cosecant x minus 1 and the cosecant squared x minus 1 goes together. This stays that. But the second one is the difference of two squares. Oh. So then, which one is this? Just factor it. Yeah, that's as factors. It would be cosecant x minus 1 squared, and then cosecant x plus 1. That would be that in factored form. The 52 is the difference of two squares. It's just that they're to the 4th. Secant squared x plus tan squared x. Secant squared x minus tan squared x. And then that one can get factored again. So that. So the odds, you can use this is the old book again. I'll put the link right there to the old calc chat. The odds you can check that way. And then the evens, I'll post the answers for the evens for this PDF, okay? Tonight's homework comes back from WebAssign, so make sure you get that done before tomorrow. You guys have a good day, okay? If anybody else has homework questions after you check your PDF, please mention them tomorrow. We'll be able to do those tomorrow and then review a little bit. You do have math, but we are together for an extended amount of time in C period, so we get all the review, whatever it is you need for tomorrow. Have a great day, guys.